Welcome to Module 3 of this course. We've learned a lot so far about the mathematics that computer science is built on. We've learned how to represent integers in different number bases that make it possible for computers to do math with them. We've also learned about the logic that both humans and computers use to process that information. In this new module, we're going to study another fundamental building block of computer science, the notion of the set. We've actually already encountered this idea more than once in the previous videos. For example, when we introduced predicates, we talked about their truth set. This was the collection of all input values that makes the predicate true. For example, the truth set of the predicate p of x, which is the statement that x mod 5 is 3, consists of the numbers 3, 8, 13, 18, and so on, as well as -2, -7, -12, and so on. We need a handy and precise way to talk about this collection, and that's what a set gives us. A set is just simply an unordered collection of objects. That's it. There are no restrictions on what can go into a set, and there's no restriction on the order in which we put things in a set. The only restriction really there is on a set is that we cannot duplicate objects. Once an object is in a set, we don't put it in again. We're using this picture of boxes for this module's videos because boxes are a useful way to think about sets. Sets are just containers. Anything can go in them. Even other boxes can go inside them, or they can be empty. The ordering of what's inside these boxes doesn't really matter. Sets are an extremely simple concept that's wide open for specialized use, and that makes them the perfect mathematical concept to drive a lot of more complicated computer science concepts of packages and containers. The objects in a set are often called elements of the set, and for notation, we sometimes use capital letter variables to represent a set, and we usually use curly braces like these to enclose the elements of a set. For example, this set T is the truth set of the predicate p of x we mentioned earlier, whose elements are the integers that are 3 mod 5. And here's a set S with just 3 elements, the letters A, B, and C. And here's a set R that contains 4 elements that are a mix of numbers, letters, and even other sets. Just like a box you might get when you buy something might contain other boxes, sets can contain other sets. Sets are foundational in computer science because every data structure you will ever use in computer science is based on sets. Python lists and dictionaries, for example, are not sets because, for example, in a Python list you can have elements duplicated and the order matters, but they do behave like sets and use a lot of the same language to describe them. Anytime we use one of these data structures, for example, to execute a for loop, we are basically working with sets. Sets in mathematics, unlike data structures in computer science, can be both finite or infinite. For example, here is a finite set whose elements are the letters of the English alphabet. And here is an infinite set whose elements are the positive integers. The 3 dots indicate a pattern that continues. This set, consisting of all even integers, is infinite in both directions. As we said, the objects in a set are called elements, and if we want to say that a particular object is an element of a set, we use this notation here, which looks like an E. This, for example, says that the number 8 is an element of this set. And this notation here, with a slash mark through the element of symbol, is saying that the number 11 is not an element of this set. We can even have a set with no elements in it at all. This is called the empty set, sometimes called the null set, and it's denoted by this symbol here, which looks like a 0 with a line through it. If the idea of an empty set seems weird, just go back to the box metaphor. It's not at all weird to think about a box with nothing in it, and that's what the empty set is. Some sets are so commonly used in math and computer science that they have their own notation. The set of integers, including 0 and the negative integers, often uses this stylized letter Z to denote it. The Z is the first letter in the German word zahlen, which means to count. Another important set is the set of all integers bigger than or equal to 0. And this is called the set of natural numbers, and it uses this stylized N to represent it. Finally, the set of all real numbers, any number at all that can be located on the number line, including integers, fractions, and numbers like pi and square root of 2 that can't be expressed as fractions, is denoted with an R. You can't list those one by one like integers. So now you know what a set is, what an element of a set is, how to use curly braces to enclose the elements of a set, what finite and infinite sets are, what the empty set is, and some notation for special sets of the integers, natural numbers, and the real numbers. In the next video, we'll look at 2 different ways to write sets. See you there.